of a force. So in previous many lectures we discussed that if we have two forces P and Q, so the resultant of that P and Q forces are, that is with some angle with respect to the any force P or Q. Now in other way we can say that this force P and the Q are nothing but a component of this resultant R. So one component in this particular direction and one component in this particular direction. So whatever the effect that is generated by force P and Q, so that will be similarly generated by the R. So either you apply a force in terms of resultant R, or you apply a force in terms of different type of forces P and Q, there will be a similar effect. Now here the question is that to find out the components of a forces or a single force. So that force is nothing but a resultant. If you find out the component, that will be transferred into a individual different forces. Here it is also important to know that a force can have any number of components. Now if you take a one R as a resultant, you find out the two component of that. Again you can also find the different component of these forces. It is also possible, right? So there are number of component you can easily find out, but generally we have two categories of components, and that components are, if you take number one, so that is known as the orthogonal components. So by name itself you can understand this is the components that is solved orthogonally. So that makes a 90-degree with each other. Right? Or you can say perpendicular. These forces are, or we can say components are perpendicular to each other. So if we draw the orthogonal components of resultant R, so we have, if this is a resultant R, and the components of that resultant R, that is force P and force Q, so that is exactly at a 90-degree, right? This is a theta with that force Q, that is also a 45-degree, and this is exactly a 90-degree. So both forces are perpendicular to each other, or we can say at a 90-degree with each other. So this type of component of a force, that is generally known as orthogonal components. Second type of components are non-orthogonal. Now in this we can understand that it make obtuse or acute angle with each other. The meaning of that is, maybe it will make a angle more than 90-degree or a less than 90-degree. So you can also say that that is not perpendicular. To each other. So if again we have a resultant R, in this also we have two cases. So we take two type of resultant, and if in first type, if that will make a theta angle, or the angle between two forces, that is more than 90, so these components are like this, and this angle would be theta, and that would be more than 90 degree. And in second case, that is a force Q and force P, but the angle between that two, that is again a theta, but that theta would be less than a 90 degree. So these are the two type of non-orthogonal components. Now here, to find out orthogonal components, we are generally use a parallelogram law. So it is very easy to find out using that. So here we write down a solution of 1, that is using parallelogram law. So we have a simple equation, that is r square is equal to p square plus q square. Because of both the forces are perpendicular, so the third term, that is the cos term, that would be 0, because of cos 90 degree is equal to 0. So we can also write down that P is equal to R sin theta, and the Q is equal to R cos theta. So this is the value of the component of that particular forces. Now if we take a solution of 2, so to solve the non-orthogonal components, you can use either by a parallelogram law or the triangle of forces. So using parallelogram law, or that would be using law of triangle of forces, you can solve this type of non-orthogonal components by both the methods. So this is all about components of a force.